to see and there are a lot of various sections. So I logically categorized all the products of AWS primarily for this exam under various categories. So compute, this is very important from exam point of view, especially for well, I mean here whatever you see the bold ones are primarily the products which I considered for both the exams. I mean, the architect exam and then the older paper and the new paper both. I mean, SC A02 and 01. But maybe I will also supplement this so that you can remove the association for SSC 002. But so these are all like bold ones. Whatever you see, these are all the products that we are that is important for the exam point of view. But one thing which I didn't, I didn't exclude the products which are under the new paper. Maybe that you can make that association with this list. But this will have products which are applicable for both the exams, the ones in bold. So that's what I mean. Definitely, you don't need to look at the products which are not in bold at all. So that is, but just a logical classification, I included them. But yeah, the bold ones are what is important for the exam point of view. Okay, right. So with that, let's start with compute. So compute primarily from the name itself, you know, it is primarily all the products under this category will bring you the compute for whatever product or whatever application that you're looking for. So primarily EC2, I think we all know about this at least. So the virtual server is what you get in internet. It's something like a virtual machine where either you get flavors of Windows, Linux, and in Linux a lot of combinations, Ubuntu, Red Hat. So a lot of products are there under this. But primarily you get an EC2 virtual machine in cloud and EC2 auto scaling. So this is primarily to scale the compute capacity to meet the demands. Primarily this will if you want to scale up the EC2 instances. So let's say you created one instance, uh, but the load is more on your system, and automatically you want a scaled up. You want three instances to catch up with the demand. So then, yeah, use auto scaling. So this is primarily to scale up your compute capacity to meet the spike of demands. Uh, I'm not looking at the other the non-bolded product, but I think I will cover only the bold ones. The batch is primarily to run the batch jobs at any scale. So this is nothing but typical batch job functionality where you can run the batch jobs on a single machine or single virtual machine or multiple virtual machines put together forming a cluster. So all these features are available in batch. So and Elastic Beanstalk is primarily to manage the web applications. So this will primarily in order to the difference between EC2 versus Beanstalk is primarily EC2 you get a bare bones virtual machine, but here you need to look at it's not just virtual machine. You'll get everything some basic softwares with runtimes like Java, Python, Node. So like all whatever languages that you're looking for. So for which you want to use the EC2 machine. Uh, for primarily, typically web application is the keyword. So wherever you want to deploy a web application, but you don't want a bare bones EC2 machine, but you want, let's say you're running a Java web application. So this comes with a JVM JDK installed, pre-installed on the EC2 machine, so that you can directly deploy your web application directly. So the input for this, for example, the Java application can directly give the binary file, the probably jar file or a war file, so you can directly give that as an input and it will deploy it into the application, so into the virtual machine. So that way, the difference is that you don't need to worry about the small things like installing the softwares on top of this. So it comes with pre-installed runtime, so that you can directly deploy your binary for a web application. So that's the difference. So EC2 is plain vanilla basic virtual machine. This is Beanstalk is EC2 with runtime, so you can directly deploy web applications. And Lambda is primarily for you to run your code in response to the events. So and and also you will not need to worry about the compute where in EC2 you need to set up everything and the EC2 machine will be running throughout unless you stop it. But whereas Lambda is it will just provision the compute on the fly to the given workload, and then it will stop it once that workload is complete. It will stop the computation. So that way you save a lot in terms of money. So that is where Lambda is more popular. Uh, so 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 the difference is EC2 is like a virtual machine always running. Whether typically your load is just for 1 hour in a day, but if you provision a EC2 machine, that will be running the entire day, and you'll be paying for the entire day unless you stop it. But imagine a small workload scenarios where you just want to run a workload for just 15 minutes, max 15 minutes. For example, that's the max for Lambda, where you cannot run any job more than 15 minutes. But if you have a requirement where you need to run particular job for 15 minutes max and then terminate. So if that is your requirement, then definitely Lambda is an option for you where it will just create the instance on the fly for you, run the particular job and then terminate it at the end of it. So you're going to just pay for that time the time for which the job was run. So you'll not pay for the entire running time of EC, like how it is running for EC2. So you'll not pay for the entire thing. You just pay for what you used. So it is so very cost effective, but it may not be suitable for all the use cases. It is primarily the limitation here is that your job can max your runtime is 15 minutes only. So if that is the case, then yeah, this will be useful. But again, also the near real time, this may not be suitable because there'll be a warm up time required for it to instantiate on the fly. So there'll be some warm up time that is required. But yeah, so it will, but if you're not worried about that, then yeah, this is the best optimal cost effective solution for you for compute purposes, right? Just moving on, and there are a lot of products others. I'm going a bit faster. Containers, again, this also come under the category of compute, but this is a kind of a next generation of compute where now everything is Docker based implementation or some container based implementation. So assuming that most of the applications, the Java applications, Python applications are all now container based model. Now to deploy these containers, we need some technology around it. So, and I mean, many of us know that Kubernetes is an open source product where you can orchestrate the containers. It is very popular and open source, and now that is part of AWS stack. Um, but yeah, prior to Kubernetes, where it can orchestrate the containers, the prior to Kubernetes came into market. So there were other products before Kubernetes came. So like AWS were having their own products. So this, for example, ECS is Elastic Container Service is coming under that category. So so basically it's nothing but ECS will run your containers securely, reliably, and scale in a scalable way. So assuming that your Java application or a Python application that is available and you want to deploy that um, onto some virtual machine. So, I mean, the virtual machine is the older way. That is what is EC2 is, which you saw here. But imagine the same thing where you want to deploy your container, Docker container, onto onto a compute. Then ECS is a solution, and there will be typically there will be a lot of containers which in a typical project there will be a lot of containers that you need to orchestrate. So you will generally host all these containers in some registry. So like Docker Hub for example, Docker Hub is a popular open source container registry. But yeah, the private version of it, the AWS version of it is Elastic Container Registry. So by the name itself, we can say registry. It holds a lot of container images. So when your CI/CD pipeline is running, so generally they download all the container images from this registry. Yeah, and then they will run it. That's all. So and every time there is a new build from developer, So they all will be via CI/CD pipeline. They will be uploaded. The latest version of the build will be uploaded to this registry, so that the registry will always have the latest code base. For example, the binary version of a code base. So that is about container registry and container service. Kubernetes is out of scope for the exam. Fargate at high level, you need to know the difference between um, the ECS versus Fargate is ECS. Yeah, this is not function as a service component, whereas this is complete serverless implementation. So Fargate is a serverless implementation, whereas ECS is not a serverless implementation. Again, serverless is again the concept which I told earlier for lambdas. So here, if you look at the lambda, so it is instant runtime that you get, and then once you complete that work, so it will terminate. So it's the same concept, just that it is for containers. That's the difference.
So Sham, go back to the previous slide. Go back, yeah. So let's give some time for people to digest, because whether they take the exam or not, right? This is the foundation.
Yeah,
Compute
exactly.
is the foundation. So EC2, we kind of showed in a couple of videos before. One on the Linux side, another on the Windows side. So any virtual machine is you could make it as a EC2. So you guys have, everybody knows what is EC2, right? Without EC2, there is no AWS. They started with this concept, virtual server, right? And the other power of the cloud is it has to scale, right? So that is the power of the auto scaling. So by looking at the name, it makes sense, but that is the power of the cloud. In on-premise, doing that was a nightmare. So auto scaling was the thing. So auto scaling goes with a load balancer, which he touched last week in the networking section, right? The load balancer and auto scaling both ties together to scale for the demand, right? And the batch. So by looking at the batch, what is a batch? It's like a batch job. That's it, right? So any batch job you want to do it in AWS batch is a service to do that. Okay, Elastic Beanstalk, it's a PaaS system. PaaS means, see, infrastructure as a code is a IaaS system. That is what the EC2 and those kind of things. You get the machine. But PaaS is a platform as a service. What is a platform as a service? You don't, I want to deploy this web application. That's what you know. You don't know what, you're not a technical guy. All you have been given a task is to implement this pretty fast. How do you do that? If you go with the usual way of EC2, VPCs, configuring everything security wise, it is going to be its own problem, right? There's a learning curve involved. The fastest way to do that is, this is a service. You just say, okay, I want to go for what kind of a thing you want to deploy: Python, Java, .NET, Node.js, Docker. Even Docker is a option. You could, if you have that in your hand, you just go to this Beanstalk, just click off, okay, choose in the screen. At the end, you can even say, I want to have an auto scaling. Everything is a click away. You are not thinking about a machine. You are not thinking about a load balancer. You are not thinking about a auto scaling. You are just saying functionally, I want this. And this is what I have: my jar file, I have my war file, I have my Python deployable, I have a Docker deployable. I know that, but I don't know how to deploy. This is a wizard guides you to deploy it in a 10 minutes time frame or 15 minutes time frame. That's the max. So that is one of the beauty of the cloud as well. The cloud became very popular because of the PaaS model. And Azure model, Microsoft Azure is even more powerful on the PaaS model, because Microsoft is good for tooling, right? So they have that strength on PaaS model, but AWS is good in IaaS model and services. So I want you guys to understand what is a Beanstalk. Beanstalk is a PaaS model, and that is what revolutionized the cloud. And the next thing what revolutionized the cloud is the Lambda, which for many of us, if you worked in last 25 years in IT, you might not even realize what they say. Okay, you have a code, you just say the same kind of a wizard. At the end, you don't know where in the Beanstalk, you know where it installs. At the end of the day, it's going to have a EC2 machine on your account. In the Beanstalk, in the PaaS model, you have a jar file, you go through the wizard, and when you say finish, it creates the EC2. And within the EC2, it puts the Tomcat server, and it deploys your jar file or war file within that, and takes your and it also configures the auto scaling block behind the scene and so on. But it's all happening on your account, on your AWS account. That is what the Beanstalk. You could see what is happening, but you are not doing the work. That's the difference. But the Lambda is even more magic. What is the magic? It is not even showing you which machine. You cannot see which machine it is running on your account. That is the power of the tool. That is happening on the AWS account. It is running on some machine, but you don't care. You should not care also. That is the, even if you want to know, you cannot know. It is a serverless way. It's like a magic kind of a thing. That's what they kind of introduced, and they take it to the next level. So go to the next slide, Shah. Any questions so far? I want to understand the basics. Let's not rush forward just for the sake of.
Actually, I want to know more on Lambda.
Yeah,
So I hear from a lot of solutioning, right? Coming
yeah.
from the lot of places, Lambda is being proposed. Basically, the API exposure of the data. Like if you want to expose somebody wants to access the data from DynamoDB or from the DB to attach to the external system, Lambda comes into play. Write a API on top of it so that expose the data. Is that how it is being proposed? How is that being used? Or
Lambda, you know what? It is like a logic. If you want, my first experience with Lambda is Alexa programming. If you have used Alexa, right?
right.
When you talk to it, you know what is happening? It is invoking Lambda, and it is invoking something on the on your account, and gives you the result back. It could be a DynamoDB. In my case, it was a simple. I created something called Chennai attraction. I did not have any database and so on. I just put together some of the hard coded 5 or 6 things you could see it in Chennai. I just returned back, okay, restaurants, choose one. Since it's a voice activated mode, you say, I want to say restaurants. When you say restaurants, it's going to go to the Chennai and it gives you 5 or 6 restaurants, what I hard coded. So you could start with a hard coded way also. But it could be fancy. It can talk to DynamoDB or any database. It can do anything you want. The only limitation is the 15 minutes. It should do things within 15 minutes. It cannot be a long running process. That's it.
okay.
Yeah.
So it is not recommended for real time at all, near real time.
Oh, it is very much recommended for real time.
It is real time. Yeah, sorry.
Yeah, but there is only one problem called warm startup. So they have some solutioning also for that recently. So one of the power of Lambda is you pay as you call, right? How many method you invoke, you pay. And that means a slight sluggish of the response time. It is still very good, damn good, okay? It's all relatively, right?
Okay.
But if you really want to have that, the best performance, they have something called, you could even say, pre-provision your Lambda. So that means you pay upfront. When you pay upfront, you don't have the cold start. So that is also coming up now.
Oh, okay.
But this is the future. This is the future.
Okay, cool.
Yeah,
Thank
I
you,
mean,
Jenny.
you can imagine it's similar to EC2 where, let's say, if you click an EC2, right? I mean, it will take at least 2 minutes for you to create a Windows or Linux box or Linux virtual machine. So there is always the 2 minutes is a startup time, the cold start problem they call. So when you are applying this Lambda on a real time scenarios, the 2 minutes, same take the Alexa case. So after 2 minutes, if it gives a response that it's not a valid scenario, right? So they have to reduce that 2 minutes time to milliseconds level. So that is one of the problem statement in Lambda. I think now they're trying to address the 2 minutes to even lesser to milliseconds level with warm up approach. But
Okay,
yeah, so that
okay.
is one of the drawbacks also in the system at this point. It is not. It's all in research level and pilot level phases. But yeah, that is one drawback. But the advantage,
No, it is not pilot level. Actually, most of the programs, if you see, most of the companies are using Lambda.
mm,
And one of the beauty of Lambda is Python. Okay, it's very much Python friendly. And it is, but what I would say is Lambda is going to be improved.
yes, it is one of the fastest growing nowadays. The products of AWS category. So
Okay,
Yeah,
okay.
can I go to the next slide?
yeah,
Yeah, so I want to give a little background. If you rush it, people won't even understand anything. I
yeah,
don't know how much I can try to explain here, but I'll try my best here. Okay, this is the new paradigm called containers. Okay, just I'm going to think try to explain as a layman term here. Yeah, can I just go in mute, please? Yeah. So we have a virtual machine. I think the echo is coming or what?
let me go on.
Yeah, from Raj, it's the
Oh, okay.
Okay,
Yeah. So,
I have muted it. Yeah, I
okay.
muted it. Yeah.
Yeah. So let me try to explain a container. Okay. This is for the sake of the diverse audience. Um, con- so far, we know how the real machine, right? The Unix machine, the real hardware machine that everybody's seen from the mainframe to the modernized machines. Then people saw, okay, within one machine, we could have virtual machines rather than one hardware, but it could cater different slices. One hardware could be compartmentalized into different machines called virtual machines. That's the next era. That's where the VMware came into real powerful space on that and so on. That was there for last 10 years, and we all had our success with that paradigm. So now the next paradigm shift is with that approach, with the virtual machine, still your operating system has to be deployed into every slice. And if you see 70% of your overhead, 60% of your overheads comes with the operating system as well as the drivers, device drivers, and around peripherals and so on. So you just have a 40% or 30%. So you are gaining, but not really that much. And now we are talking of a bigger computing in a very fast in the same storage with the same capacity compute. Can we get more? The compute, we are not thinking of increasing the compute. The machine is same machine, but can we increase the computing power? That is where the containers came into picture, where they say when you package your code, you just don't package only your stuff, package along with your layers. So for example, if I'm a Java, I would say I need a Java and I need a Maven and I need to have other JDBC things and so on. So I will define my layers in the Docker file. Once I define the layers, the beauty is that the new way of deploying, the containers way of deploying, it will work on your laptop. The same code will work on your server machine, and it will work on your any cloud. It's that is the paradigm shift. It's called the cloud agnostic way of deploying to maximize the cloud compute. So that is where the container. This is why the last 3 years this is a new hype, and this is going to go for next another 3-4 years for sure. And the improvements will be on top of it. It's not going to go away. So right now, when we say containers, it's on top of the virtual machine, right? So it is not going away. You are not replacing a physical machine. Your physical machine is there, virtual machine is there. On top of the virtual machine, what is the best way to optimize the compute is the container. There will be something else which comes to even improvise on top of this. But whatever we are learning is not going away. That is a good thing. So hope you guys understand what is containers here.
So Srini,
Yeah.
so in this particular case, so when you are deploying this kind of the Docker, sorry, the container. So the architecture in this case is after the virtual memory, you then install the Docker, and then Docker manages the container. Is my understanding right?
Yeah. So it's basically I just gave you the evaluation of the computing, but Docker is a package which you could deploy it across your local computer to the server machine to the cloud without changing the code. It will work. That is the promise of the package.
Okay. Okay. Thank you.
Previously, that wasn't possible at all. The portability was the biggest issue.
Okay.
Okay. So yeah. Anybody else has any question on the Docker and container and so on? So once you know container, to store the container, you need to have a registry. That is all the registry, and every cloud provider has their own registry. Here, Amazon has this Elastic Container Service as the registry. Okay. And Fargate is the one. So Lambda, I told you, right? Lambda's power of Lambda. It is running in machine, but you don't know which machine. That is the power of Lambda. Same thing, container, it is running in a machine. You don't know which machine it is. That is the power of Fargate. And more, I think now Kubernetes. Kubernetes is nothing but container orchestration system. That's it. To orchestrate. If you have so many containers, how containers life cycle will be managed? Nowadays there is going to be thousands, and it's reaching millions, because every company has small things. If they wanted, previously it was executable, now it's all dockerized thing. So there will be, previously if you are a Java shop, you have only Java executable, .NET shop, .NET executable, PHP shop, PHP executable. Now common denominator, Docker executable, one executable across. That is the beauty of it, right? So the runtime, it is called a polyglot. So language agnostic. You could choose your language. You could write your programs. You try to package it this way, then it's a common denominator to deploy it. Doesn't matter what's your source system. That is also one more power of containers. Yeah, some of this might go a little above, but I just, since it's recorded, if you guys have interest, after this, if you Google around, you will get more ideas. Yeah, continue, Sean.
Okay. Okay. So far we got an idea of, so we have virtual machines. In the virtual machine space, there is a serverless area. So this is physical server, but this is a short period of server that you get, and then that will vanish once the job is done. So it's not running for whole day like EC2. So an evolution to this virtual machine is containers. In the container world, so again you have the the serverless component also is here, and the non-serverless component is also here. The non-serverless component is ECS, and the serverless component is Fargate. So that's about the container aspect. Now,
Shyam, just a quick question before we move on. Sorry,
yeah,
sorry for the interruption. Probably Sini also can pitch in. Regarding this Lambda, it was mentioned that it will run only for 15 minutes. But before executing the job, I might not know whether it will go for 15 minutes or 17 minutes or 20 minutes or 8 minutes. So in case if it exceeds that 15 minutes time, what will happen to that job? And if the job is completed only say 70% because of load or whatever reasons, but what will happen to that job? Will it get aborted or will
it
it
will be
still
aborted.
wait or what will happen?
It will aborted. It will be aborted. It will be
Oh,
interrupted. Like Control C, if you stop it abruptly, what will happen? The same
right.
thing will happen. Yeah.
Okay. So, okay, fine. So
So
in that case,
basically,
I have to
your
run.
use case is so you have to predict that. So if your use case is we're talking about a couple of minutes, like 2 to 3 minutes or 5 minutes of so basically you can't put a lot of logic inside this. So that is
Okay.
the concept. So if
So I
you
have to
need
be absolutely sure that it will run probably within 10, 12 minutes so that
exactly,
even if it overshoots, it will get completed within that time.
exactly, yeah,
Okay. Okay. Thanks a lot.
yeah. Okay. So next is the database category. So here in the database, I think more or less at least either would have, the people in this group at least partly somehow would have worked in at least different one or two databases in their lifetime. But so with that assumption, if I see there is this database category uh, is one of the cloud provider where they have database support for all the possible combinations that we talk about in the market now. Everything they have a service. So in this database space. So AWS is a master in this area. Um so if you talk, the database will have. I think we saw the evolution of databases. So it started initially with RDBMS, then the NoSQLs came, then after that, in the NoSQL category, there is a lot of further developments happened where document-based database and generally we store the records in rows, right, in RDBMS. So if row one is one record, row two is another record. So then why can't we store this in columns? So the columnar databases have come, and also we have graph databases, which is very new addition to this. So likewise, this database, also the time series based database. This the generation of databases. So it is it evolved over a period of time, and so there is a solution for all the databases that you think. There is a solution in AWS. So
Hello?
Aurora, sorry, was there a question? Okay, so yeah,
Sorry.
sir, was there a question?
No, I'm thinking I'm okay.
Oh,
You
okay,
can go.
okay.
Yeah, Jnana is also joined. Yeah.
Okay, okay.
Yeah, go.
Okay. So in the database area, so I think the most, I mean, we all started with the relation database. So RDS. So this is if the questions anywhere talk about the relational database for the scenario that was asked, if they are looking for, we are planning to develop the scenario based question, something like they're looking for a relational database. If there is any question like that, so the RDS is your database selection. So RDS is a relational database, managed relational database service from AWS. But this is others are all individuals, but the only exception for RDS is it's a group, meaning in this RDS group there are multiple individual databases are there. For example, you have MySQL, which is RDBMS, Postgres, popular open source RDBMS, these two are open source RDBMS, Oracle proprietary, SQL Server proprietary, MariaDB is open source. So, but yeah, there are other popular, I mean, other databases are also there in the relation database category. But yeah, these are the popular ones that whatever is there in the market, they are all supported with RDS as a component. So yeah, RDS is a group. So that's what you need to remember. So it is a managed relation database service that you get supporting MySQL, Postgres, Oracle, SQL Server, MariaDB. So these are the six databases. Sorry, six. Yeah, five. Yeah, five databases that are supported. Um, And apart from, I mean, when you say managed, you understand, so it's completely managed by AWS. So all the version upgrades of these databases and all the patches, everything will be managed by AWS. So you just need to yeah, set up that, and then you can forget it. So you can just use it for your requirements. But managing the database, so that is completely managed by AWS. So that is the beauty of RDS. Um, and it, so every cloud vendor, if you take, they promote a particular DB of which is developed on their own. So these are all not developed by AWS, for example, right? So MySQL, Postgres are all not developed by AWS. These are all open source products, and some of them are proprietary of other companies. Um, so what is in-house developed product, and which is heavily marketed by AWS, to look at, that is Aurora. Okay. So again, this also is under a relational database category, and but this is in-house developed product of AWS. Uh, so so uh, so wherever, if you go to RDS category, they will try to force you to move towards Aurora because that is their own proprietary. They can, so all the popular features are available in Aurora. Aurora is, for example, they didn't develop a new language altogether. They developed on top of on top of the libraries of MySQL and Postgres. So that way you need to learn a new language. So it supports both MySQL and Postgres in Aurora. So for any of your MySQL or Postgres requirement, compared to RDS, Aurora is a better choice if you want to stick to AWS. So what the specialty is, this gives, as per their marketing of AWS, at least the MySQL, it is 5x times better performance than the typical MySQL, and at least 2x or 3x, I don't remember. So it is 3x, I guess. So 3x performance, better performance than Postgres. So that is what Aurora is. So yeah, in the question, if you see anywhere RDS, relational database, uh, so if it is yeah, RDS is like either Amazon RDS or Aurora. These are the two options. So if any question is talking to relational database structure, um, anything on the most performant RDS, then it's always Aurora, because Aurora is best performance compared to all the other all the proprietary available under RDS category. And then, so that's about the relational databases. Then coming to the NoSQL category, so DynamoDB is there again in-house developed product under the NoSQL category. So so yeah, so this also is more popular because it's again in-house product of AWS. And Elastic Cache, this is primarily for a caching system. So typically, in-memory caching is one of the common architectural pattern where in a scenario where you need to do a lot of reads, your application does a lot of reads to database compared to writes. I mean, you understand the difference, right? The reading is doing a select star from, for example, on a table. Okay, that is what is read. Uh, but when you're writing, you're doing an insert or update to the database, right? So but if you are an application where a Java application or Python application, so your application is basically doing a lot of reads than writes. Okay, so on and off it, the writes is fine. The overall the writes are less, like inserts or updates are less, but you do a lot of reading from the database. So just reading. So in that case, the most common pattern is that before a database, they generally have a caching system. So that way, the advantage of this caching system is it caches all the incoming data that is coming in. It is like a database before database. Like, so you're having a in-memory database which is sitting inside your memory. So because it is faster, that way your reads will be more faster. So the flow will be any application. If there is a cache system before, first it will go to the cache. It will look in the cache first, which is in memory, so it is faster. If the data is already there in the cache, it will return the data. It will not even go to the database. It will push the data out as a response back, and this being in memory is faster. But let's say the data is not there in the cache, then it's a new record that we're talking about. So then this cache will go and talk to the DB and then get the data. And it will store this data again in the cache so that the next successive request will be served from the cache rather than going to the database. So that is a typical caching concept in a typical web application. So to support that caching feature, a lot of caching systems are available, but Elastic Cache is the most popular open source DB. So that is again, that is the open source model is taken and they customized it for the AWS purposes, and they made it as Amazon Elastic Cache. So it's nothing but an in-memory caching system. So if you see any questions regarding caching, your answer is Elastic Cache. Okay. So the scenarios will be like the questions will be around your. I have a this is a web application. The requirements are need to. I will do a lot of reads rather than writes. Then I already have a database, but it is all it is taking a lot of time. So how we can improve the system? Answer is bring Elastic Cache before your database. So it acts as in-memory DB so that your responses will be faster. So that's the answer for the scenario for the Elastic Cache. And then so far we saw the relational database category, RDS Aurora, and the NoSQL category DynamoDB. Then caching system, Elastic Cache. Then other categories, the data warehousing. So if you go beyond a database, so typically in a big data kind of a scenarios where you need to, you'll have a lot of requirements where you need to plug the data from multiple databases or pull the data from various file sources or any other third-party systems. So you need a warehousing kind of a solution. So that is where Redshift is a solution for you. So in the questions in the exam, so anything on the data warehouse, answer is Redshift. Okay. So yeah, and then this is all under databases category. So then there is also database migration. This is a migration service. It is not a typical database, but it comes under the database category. Let's say you want to migrate your on-premise database to a cloud, okay, or you want to migrate database within cloud, for example, from you already have a cloud, you're already using RDS, for example. Let's say your Aurora has better features, so you want to migrate from in the cloud itself from RDS to Aurora. So then you need to migrate this data that you already have to this new system. So that is one use case where within the cloud you want to migrate between databases. Other is let's say you're first time you're moving to cloud as an enterprise company, you're moving to cloud for the first time. So in that case, you already have an on-premise setup, on-premise MySQL or on-premise Oracle on your local your enterprise. Then you want to migrate all your data to cloud. So yeah, these are the two scenarios where database migration service, the last one will come into picture. So yeah, any questions that you see on migration with minimal downtime, database migration service is your answer. Any questions here?
Shyam, while going through the Excel, I see that there is a confusion between DynamoDB and Redshift. But now I see that Redshift is a data warehouse, whereas DynamoDB is a database. So that is the finer difference I think we need to make in the question, right?
Exactly. Yeah. Right.
Okay.
So
DynamoDB is a NoSQL database.
yeah, in the database category, another differentiation is there, right? So relational database and a non-relational database. So DynamoDB will come under the non-relational, which is NoSQL category of databases.
Okay.
Yeah.
So let me try to explain. What is a NoSQL database, because for many people they all know tables, right? But beyond that, this is a next generation where in a database table, you will have a primary key, you will have a set of columns, and you might have a foreign key, and you'll have another table. That is what many people know: department, employee, address, blah, blah, blah. But in NoSQL, if you want to do the same thing, for example, a department can have many employees, and employees can have addresses, department can have addresses. So in RDBMS, how do? You have a department table, you have an employee table, you have an address table, and you have a foreign key from department to address, and from foreign key from employee to address, and foreign key from department to employee. So far the use case is clear. So,
Yes,
yeah. So
yes.
if you have to implement this in the NoSQL, how do? You don't want to think of as a three different table. You just come out with one table, okay? And the primary key for the table is a ID, okay? So you specify a primary key, and your primary key will have it could be used as a uh, camouflaged ID also. You could store either department ID there or employee ID there, blah, blah, blah. But in a summary for this use case, you will have like a JSON kind of a thing. So instead of storing column by column, you kind of say you just specify one ID and you can put anything garbage in, garbage out. So here you could say department ID. The rest of the things could be department ID will have employee details and the address. Another department ID will have warehouse details and address. And you could even have non-department ID. You could have a just an employee ID with the details. With one table, you kind of camouflage the data so that you kind of what so if you really, this is going to be challenging for people who did so many years of RDBMS. No, it is not third normal form, second normal form, first normal form, all those things, right? All those things you have to throw away now. Now you have to think from the other side of the story. Oh, okay. What this gives me is it removes all the barriers. If you have such a fixed, rigid structure, the scalability was the biggest problem. When you go beyond a millions, the RDBMS, none of the RDBMS could able to handle the load for Amazon. That is where the R&D team came out with this kind of a NoSQL way of approaching the problem. And the use cases for this are like a gaming. If you're trying to come out with a gaming system, and you might if you want to capture something about your Facebook metadata or geospatial metadata, you don't know what the exact kind of data you're going to get. You know you're going to get the data, so that means you specify the ID, the rest of the information what you gain, you just can able to persist on this. One more very good use case is the IoT kind of a data. Every device can split up their own data, but if you have to come out with RDBMS way of doing it, it's going to be ageless, right? You have to keep on the data itself is varying a lot. So how to camouflage so that you could able to do it very scalable way is what the NoSQL. I'm just giving you the overall functional side of it. Technically, there are many ways. I'm not going to go into that, but this is a paradigm shift. So when you go for a NoSQL, you might go for one or two or three maximum table. That's it, not beyond that. But you could store umpteen number of functional details within the same. Querying is always the tougher way, obviously, and there are ways to mitigate it. I'm not going deep dive into how to do those things. That will be a separate session. But the what you guys have to understand in this cloud era is whatever happened 20 years before, those things are all still there for the sake of there. That's it. But things have evolved a lot more for better. And previously the consistency was the biggest thing people were talking. Oracle was the biggest consistent database. Nowadays, eventual consistency is what the winner. So you have to choose for applications. See, not all the applications need a real consistent thing. If you need your bank credit and debit, yeah, it makes sense. But for uploading the messages to some for Facebook or Twitter or any such things, you don't need to have a consistent. If you lose something, it's fine. So that is where the power of eventual consistency database, NoSQL database comes into picture.
So
Yeah, that's it. I just want to give you a high level.
so the NoSQL stands for not only SQL. So it is mainly key value pairs. The bottom line is key value pairs.
Yeah.
And what you do is, what is the backing is, it's not a strict, rigid, structured format, right? It is meant for unstructured data, like a log file or an IoT event, whatever. You put on top of it, you put some kind of a middleware or engine, which you can query like a database, but it's not a real database. That's the crux of NoSQL. That's it. And that is usually good for unstructured data, like anything that you get, like you want to read an email messages of all these people in there. So that's, you can put NoSQL on top of it and start querying it. So that's where this stuff comes in. And I think, so that is,
with this list, actually S3 should also be in there, because even though it's not a database, it's an object store, right? And the way in the big data world, how things are evolving is the S3 is the place where you could put video, or you could put audio, or you could put any unstructured things.
Yeah.
But the problem with that is you don't know, you cannot query that. Then you could put the metadata of what you put in the S3 in the DynamoDB. So those two are the killer combination. Wherever people are using S3, they will store what they stored in S3 in the DynamoDB. That's a very popular use case.
Yeah, I think the S3 is logically under the storage category. Yeah, but another way it is also a database. It's an object storage. So
This is one of the questions I wanted to ask you, because we store actually in our company a lot of PDF files, CAD diagrams, and other stuff in terabytes. So I think the DynamoDB with a combination of S3, basically most of them are OLE objects.
Perfect combination. Those two are the killer combination. And if you have any videos along with it also, yes.
Oh, I see. Okay, thank you.
The
so
S3
what I
will.
believe is the basic difference is that. Sorry,
go ahead. Yeah, please.
Okay, the asset properties in the traditional database is gone now. I think that's it's not valid anymore.
See, in DynamoDB, that is the beauty of DynamoDB. If you still want ACID, can you do it? Yes, you could do it. But is it really fast? No, it is. It is going to be expensive also. See, in the cloud era, you pay for what you get, and that means you don't need to have ACID for those use cases. If it doesn't want to be ACID, you pay less and go for the eventual consistency.
Okay. Yeah.
I think one thought from the practical point of it, if I may add, in any relational database, I think having worked in that for many years, the changing a new if you want to add a new element of data, you have to change the database, you have to change the code. It is a big problem. And those people who have been working in the development side, they know to make a change, you recompile it, to test it, to deploy it, it's a nightmare. In a large application, that's a pain. So unless you know the structure of the data, which you already know what you want to capture and the type of the data, RDBMS will not probably work. But in today's context, when nobody knows what I am going to get today, what data I am going to get tomorrow, when there is no certainty of it, I cannot define a database structure today. And I think that's where the free form or the NoSQL kind of the database comes in. I think that's probably where I see all the
that is one of the powerful use case. And perfectly on the IoT world, every sensor is emitting so many data, and every data people wants to capture it. They cannot keep on creating tables for every one of them. That's where these are all the real things.
Yeah. Okay, just off track for this, not for the exam, but I think there are other databases also there. For example, this IoT use case is mostly this time series DB is where it is primarily meant for an IoT use case, and also for for a Facebook or a Twitter graphing kind of a structure, like this person like this person, this person like that person. So where you are forming a hierarchical data structure. So that's where the graph database comes into picture. That's where this Neptune is for that. I think yeah, it is, and MongoDB is another popular NoSQL database. So and yeah, they provided a compatibility for MongoDB. It's not the MongoDB as such. It is a compatibility, so which is called DocumentDB. So it's also under the NoSQL category. Again, these are all MongoDB is an open source. So the version of that is this DocumentDB. But DynamoDB is AWS its own NoSQL solution. Similarly, Aurora is also in the RDBMS category. They have their own solution, but they didn't develop a new language. They provide integration to MySQL and Postgres. So basically, typical MySQL database can easily migrate to an Aurora DB, or same thing. Postgres also can directly move to Aurora DB. And yeah, but with the better performance and better features. So that is the beauty of that.
So one question, since Sini brought up S3, right? S3 also stores the similar kind of unstructured data, like, we can just store that also there. Question comes is now, when do we use DynamoDB? When do we use S3?
So DynamoDB has a maximum limit of 400 kilobytes.
Okay.
Cannot store more than that. So but S3 there is no limit on the size at all. So S3 is meant for data lake, for the big data, right?
Right.
But you could store the metadata of it so that you could query. The problem with S3 is you cannot catalog. You don't know, it's garbage in, garbage out.
Correct. Okay.
To give a meaning to what the madness, so that's where the DynamoDB comes in the front.
Got it, Sini. So basically, if unstructured data, I put it into S3 and then you want to catalog it, we can go for a DynamoDB and then query on top of it using Athena.
Yeah.
Okay.
Yeah.
Okay.
Right. This DynamoDB, primarily the use case is metadata is what is stored in DynamoDB in combination with S3. So S3 will store the physical object, PDF or whatever, image file or whatever, but the metadata of that information will be stored in DynamoDB. So whenever an application wants to read this PDF file or an image stored in S3, first it will reach DynamoDB and get the metadata. Like for example, what is the S3 URL where this PDF file is stored? So that only that is metadata. So it will not have the physical object, but it just have the location details. So that will be fetched from DynamoDB, and then the flow will go further and fetch the data from that location from S3.
Okay. Got it. There is another use case. Yes, definitely.
Okay, so that's about the database category. So then networking, I think we looked at details more in the, I think it will be more familiar for most of us, that is people who attended before sessions. Yeah, we know that VPC, so this is nothing but isolated network where you can access all your cloud resources within your boundary. So, and we saw all the various subcategories under VPC endpoint and VPC subnet, so all those things. So all those things under broader umbrella of VPC. So and but the VPC is one of the most popular component under the networking, but there are other products also are there. So for example, API gateway. This is primarily to manage, from the name itself is there. So it is managing your APIs. So generally you will in any traditional applications, there will be a lot of APIs that will be there. So it is managing one or two APIs is easy, but imagine there are thousands of APIs in an organization. So it will become tough. So to manage that, so we have the solution from AWS is to API gateway. So if you see any questions on managing or building and deploying stuff or managing the APIs, so the answer is API gateway. So this API gateway is primarily it will help you to it will be kind of an entry point before it actually calls the actual API. So this will be a layer in front before the API. So whenever there is a call, a request that is coming from some browser or some client, So first the flow will, I mean, there are other components before API gateway also in a typical architecture, but like for example, load balancer or for example, even the Route 53. So likewise, there are other components before API gateway, but but just before the API, the box is API gateway. So, but again, it is not mandatory to have an API gateway for a typical API based architecture. But it is good to have, especially when when it is like you're managing a lot of APIs. So it will be tougher. So API gateway is a solution where you have to manage a large number of APIs. And then next is this CloudFront. So here this CloudFront and also a lot of, I mean, TPC and CloudFront and Route 53. These are the popular exam point of view important stuff. So yeah, spend more time here. So CloudFront is typically the static content that you want to stream the data faster and where you have static content available. Let's say imagine your typically is a web application where you have a lot of images in the application. So typically in a web application, the images will take a lot of time to load, or if you have videos, for example, it will take a lot of time to load. So to reduce the time to load, so AWS came with a solution called CloudFront where it will cache all the uh, images and videos kind of a thing. It will cache it, so that way it will not go to the real physical database or S3, or it will not go there. It will directly get this information from the CloudFront itself. But the advantage in CloudFront, where how it is faster compared to a database or any other EC2 machine, is that this is it is a global content delivery system. So it is, which means it is global. So which means it will, the content that are cached inside this will be replicated across multiple regions. So that way, any request that you get from any different any part of the world, so this CloudFront is stored in all the regional locations. So that way, your data will, images and videos will be loaded faster. So it is a combination of what to say, this the caching and content storage and networking. So that is what it is. So in a typical architecture, this will be something. It will be in the front. So as and when you get a request, right? So this guy should know whether do I need to cache it or not. So only if this guy needs something, only then which is not already cached, then it will go and fetch the data from your EC2 or a database. So generally in your typical architecture, CloudFront will be something in the front. So yeah, that is about CloudFront. I think the next one is Route 53. I think we saw this in our last session. So it is nothing but a domain naming system, and it is also scalable. So the yeah, typically www.example.com. So that's a typical domain system that you can buy. And also we saw that it is also having a lot of use cases around, like you can set a lot of rules there, like how you want to do Route 53 to work. It could be, we saw that it will be based on various geography based content, or you can do weightage based content. So likewise, you can apply a lot of rules based on that. Route 53 will yeah, will divert your load accordingly based on the rules that you configure. But at the end, it is any question on domain naming system, or any questions related to like domain name. So answer is Route 53. So, but in that, yeah, you might have to deep dive on the features, because it is kind of feature rich. So there could be questions on specific to features, for example. But I think, yeah, that will be the other session which I had gone through will cover the features inside Route 53. Yeah, so that's about Route 53. And the next one is private link. I think this is I think we also covered this. So it is private link. All the I mean, public way of data going out is not secured. So nowadays, all for security aspect, all the data transfer, they want to make it private, so without internet. So So yeah, so this is a private link is a solution where you want to securely transfer the data, and especially you want to transfer the data without internet. So that is what is private link. This direct connect, I think we saw that. So dedicated network connection, and this involves a third-party vendor who will be in between. But yeah, so you can transfer your data from on-premise to cloud. So this comes under the category of on-premise and cloud combination. So yeah, so the questions under this networking category. So far, whatever products that we saw so far above, yeah, I mean this will not come under the on-premise category, but on-premise category, on-premise cloud combination. If you see any questions, yeah, of course, VPC is a broader umbrella, so that will come under that. But under that, this direct connect, transit gateway. So these two are and VPN, which I didn't mention here. So this comes under other slides. So VPN. So these are the on-premise and on-premise data center and cloud data transfer. So that in that kind of use cases, this direct connect and this transit gateway all will come into picture. Then global accelerator. So this also we at least we know that global accelerator is primarily again performance aspect. So it will intelligently identify what is the AWS will has a broader worldwide network. So based on where you are, so it will automatically intelligently identify the nearest network, and it will transfer the data faster. So that's where you get a better performance over the network. So that's where this global accelerator will help you there. So any questions where you see the intelligent routing or data transfer, fast performance, improve the performance of the network by intelligently routing stuff, then answer is global accelerator. Then also we saw transit gateway. This yeah, between two VPCs, it will be difficult once the VPCs are growing. There are the use cases are like a lot of VPCs are there, and managing that will be tough. So so basically, two VPCs or multiple VPCs you want to connect. So then transit gateway is your solution. So it is one place you give the configuration to transit gateway. All the VPCs will get that information in one go. So and yeah, then load balancing also we saw. So where it will distribute the incoming traffic to the multiple targets. So typically in your architecture, the your I mean, if you exclude the client side, I mean, once the client has made a request on the server side, the flow will be in a typical end-to-end architecture. There'll be CloudFront that will come first, uh, then followed by the Route 53 because it's a domain name, so it should identify which private IP of EC2 this your code is available. So it should identify that. So that IP from the domain. So converting that domain to IP. So that will be done by this Route 53. So CloudFront followed by Route 53, followed by Elastic Load Balancer, and this load balancer will know under this load balancer there will be a lot of EC2s will be there. So our EC2s are containers, ECS containers. So based on that, this guy will decide that the response is available in this EC2 machine, and then it will transfer route it to that, and then you will get the response back again, and it will be given back to the client. So that's the typical flow under this category. Okay. So, but VPC is very important from exam point of view. So, I think we have spent enough time in this area. So, I think it should be overall compared to other products. I think it will be comfortable in this area. But yeah, if you're seeing it for the first time, please spend more time under VPC. It's very important from exam point of view. Okay.
And one more thing is when it comes to cloud, you know how cloud became very famous or very practical because of the CDN, this CloudFront concept, right? Assume that this concept hasn't evolved, then I don't think cloud would have picked up so fast. So with all the humongous video audios across the globe, across region, people are sharing, and there are thousands of applications, actually millions of applications. How things are really working, that's because of this clever idea of, even though your real things are all distributed, but I have one place near to your region. So for example, in India there'll be couple, how many do you know, Sham, how many edge places in India? So every place in India, in US at least 4 or 5 are there. So that is where, based on your geo centric, from where you are making a call, the if you have the cloud front in your architecture, that would make the your solution seamless, whether it is cloud or not cloud. That is the real secret sauce.
Yeah.
You could even translate, for example, based on your edge things, it could even translate and show what you want to see on the edge, so that your primary, your code might not have those things. It's really a common thing you deployed, but any customization based on the geo language specific and so on, those could be augmented based on this CDN architecture.
Yeah. So that's why it's called, for example, content delivery. So I mean, content delivery category is primarily, CloudFront is your content delivery system. So anything that you see a question on content delivery over the network, then CloudFront is your answer. Okay. So let's move on. So then security, identity, and compliance. So this is also very, very important from exam point of view, because security is one of the base on which all these products are developed. So I think it's not just IAM. IAM is the product. Everyone talks about IAM as security, but it's not just IAM. There are a lot of products under security category. In the last 2 years or 3 years, a lot of products were added under the security category from AWS. So it's not just and the list goes on. I mean, a lot of products are being added under the security category by Amazon. But yeah, but very, very most popular product which is there from day one is IAM, identity and access management. So this is primarily to manage all access to various services. This service a lot. I'm talking about the various AWS services what we saw so far. So we can manage the access, which is primarily the authentication and authorization part. So it is access, authentication, authorization. So that's where IAM will play a major role, and also it is global. I mean, not all products are global, but IAM is a product which is global. I think even content delivery, for that matter, is also a global product. So so there are some products which are global, but yeah, IAM is one of the category of product where it is global. When I say global, it is like you can access this in, I mean, in whatever region you go in the AWS regions. Let's say you created a user in IAM in US East region. You can go to Europe region within 2 seconds. Within there will be one minute difference. You see the same data that is replicated even in Europe region also, for that matter. So you can whatever data that you're entering here in IAM is global. So you can access it from any region. So that is very, very important from exam point of view. So it is a global product. Why global? Because this is a base data, right? So I mean, adding users, managing the access, security. So these are all very important. So which product, who should have access and what access he has. So that's why they wanted to maintain this as a global product. So yeah, and so yeah, it is nothing here. IAM is nothing but your the three things that you need to remember is the users, groups, the permission of roles. So permission roles basically. So typically, you create a user. Yeah, you'll associate uh, this user to a group. For example, developers is a group. So Sham will be, if Sham is one of the developers, Sham user will be created and he will be associated to the developer group. Srini, for example, let's say another group called architect. So he will be associated with another group of architects. So that's why it is easy to manage the groups rather than individual users. So and then we can also assign permissions. So what Srini can do or what Sham can do. So those are all permissions that you can provide for the particular user. So any product that you, any other AWS product that you access, it will first check whether you have the required permission for you to execute, or do you have the required privileges to execute that product. So that's why it is a very popular product, where this talks to all the products for that matter. So it's very important. Yeah, so once you have that, then yeah, you'll be given the required privilege to execute. For example, you want to execute a query in a RDS database. The first step is, after you create an RDS database, let's say no MySQL database, you need to you need to give permissions for your user IDs to access the RDS database. So without doing that, even if you create a database, you'll not be able to execute. It says permission denied. So yeah, the permission is all should be configured here. Only then you can access. It's not just a database for that matter. Any product of AWS, you should get the permission configured here. So okay, so that's about IAM. Very important from exam point of view. So you spend a lot of time here because VPC on the in the security IAM. These two are very important from exam. I mean, also in this the compute side. The EC2 is also equally important. So uh, yeah, and then these are all the additional features. These are all the products which are added on top but they all come under the category of security. But from exam point of view, you need to know at a high level, so that's sufficient. So for example, Cognito is primarily for our apps, mobile apps, and identity management for your mobile apps. And also, this Cognito has a lot of products where you can app sync. Is another product under Cognito App Sync. It will sync all the various mobile apps user information in one place. So likewise, it is more about managing your apps at the security level. Then guard duty is again threat threat detection service. So anything you see questions on all the malwares and threats that is happening. So basically, this guard duty by the name itself is there. It can do the guard job. So it will guard your system to avoid all the malware and other threats that are happening. So it will runtime. It's all managed service. So AWS will manage in ensuring that this guard duty is up to date with all the malwares that are happening, all the new malwares that are every day new malwares are coming out. So it will ensure that all this all taken care. The solutions are all taken care under this guard duty. So it will just keep on looking for all these threats and it will highlight or inform. Then inspector is more about your application security. So this is more at like a network or internet level, internet layer, but an application also can have a security block holes. So the application, I say any application that is developed by the developers. So at that level, if you want to see, it's kind of a scanning your code base and identifying what are the black holes that has to be taken care. So it will analyze your application security of your application, and it will give you recommendations based on that. You will just give the recommendations aspect, but nothing more. But yeah, you need to fix those recommendations basically. So um, but yeah, and then I think this is very common. If you look at any of your organizations, so at least they will be using some products under this category. Any new application that is getting deployed for the first time. So typically, when we should get an approval from security administrator to ensure that they will use some tools and they will do a scan of your software and tell that hey, you opened this public this port is opened or you are directly using password in the code. We should not use that. So that kind of recommendations is what this tool is inspected. So then this is Cloud HSM. This is the security at a hardware level. So for whatever you're talking is all at software level. But imagine there is a hardware-based security where you are using keys, RSA tokens and keys. So similar to RSA token most of it have used. So it is something like a hardware-based security implementation. So similar to that, if you want to have your own enterprise hardware-based security system similar to RSA tokens, yeah, you can use Cloud HSM. So that'll primarily come under the category of the regulatory compliance aspect. So that is so some security aspects where regulatory is mandatory, where you need to use, apart from your user ID and password, you should also use some hardware-based key storage system where you'll looking at some RSA tokens equivalent, and then kind of an additional authentication. So that kind of a requirement, then yeah, your Cloud HSM is your solution in the AWS space. And then this key management service. Again, you're talking about I mean, any typical application. There will be a lot of secrets and passwords. So, for example, database user ID and password itself. Password is a security aspect, right? So we should not use the password directly in the code base or anywhere sitting outside. So it should be encrypted even in the code also. So for that, there is it's something like equivalent to a vault kind of system where it will secure your passwords, so that there will be, it's like a key and value based system. So you store your password as a value, and you will associate a key to it, and in the code you will use the key rather than the value. So once you do a get off key, you will get the encrypted password as a response, and that is what you will use in the code. So that kind of a encryption based implementation is what is key management service. Then next one is the resource access manager. This is to primarily to secure your service and also to share primarily the AWS resources. For example, this is where let's say there are two products within AWS. For example, take the VPC itself. So let's say I'm in VPC A and there's VPC B. There are two VPCs are there. So you will not be able to access the components from VPC A and VPC B. They can't talk to each other because there is no connectivity. But if you define a resource access manager, which is a component sitting in between both of your VPCs, so then basically you're sharing your VPCs, uh, and you're creating a boundary within that. So I mean, I'm just giving VPC an example because uh, yeah, two VPCs are not possible to share. So likewise, there are other products in this AWS space where where they have their own boundaries. So for such cases where temporarily you want to give access between two bounded systems, then that's where resource access manager will come into picture. So it is primarily to it is nothing but a shared component where one bounded system will put the data into the shared access manager, and the other component will read this data from the shared access manager. So it's like acting as a bridge between two boundaries. So that is what this access manager is. It's primarily coming under the category of two products having their boundary. They can't come out of the boundary for some reason, but they want to talk. Then this resource access manager will be in between, acting like a bridge. So and then secrets manager. So this is more or less similar to this KMS, but the difference is that this is more about rotating your secrets. Like this, generally this passwords should be changed for every 90 days, for example. So you want to configure your own rules, and you want to rotate the keys. So that is the secrets manager, where it can manage your secrets well. So you can put a rule and ensure that this is changed, or at least inform me when this when it is nearing, for example, 90 days. So it will it will inform you by emails or whatever. So, and you can change the rules or what, and you can change the secrets or change the passwords. So it's more about managing your passwords in a better way. So that is this secrets manager. Um, Shield, Shield from the name itself, it is like it primarily takes care of the DDoS protection. So yeah, I think DDoS attack is one of the most popular after this IoTs have come. So DDoS attack is most popular threat these days. So primarily to address that DDoS attacks, Shield is primarily a solution to that. Yeah, I mean any questions on DDoS, then Shield is your answer. So next is a single sign-on. So yeah, I think it's a very common product. So like you have single sign-on. Like you want to you entered into your laptop, for example, with your user ID and password, your employer user ID and password, LAN passwords. But you don't want to enter into your internal systems with the password, same password again. You don't want to enter. So single sign-on is a popular feature that all products like Microsoft also has their own solution, and all the other products also have a similar solution, so single sign-on feature. Um, so yeah, so AWS has a solution for it where it has integration with all the popular market products come under the single sign-on category. So yeah, this will help you to manage a single sign-on feature on the cloud. So that is a feature. Next is WAF. Uh, so it is primarily this WAF is primarily web application framework. So this is primarily to take care of your web traffic, the malicious web traffic, primarily under layer 7 category. So layer 7 is typical networking layers, if you remember. So layer 7 is your HTTP traffic. So the HTTP traffic is more prone to attacks. So this primarily focuses on the HTTP layer 7 level traffic, and it looks at the malicious aspects under that. And yeah, so that is primarily this WAF and Shield. Generally, they go together. So primarily, I mean, it is nothing but they are all the requests they come through various inputs. So any request that is coming in. So this guy will check for this DDoS protection, and this guy will check for the typical web traffic or any malicious content that is coming in as part of the request. So that will be validated by this graph. Because once the malicious content comes inside your network, it is difficult to manage. So yeah, it's all the layers. These guys will sit outside your before they enter your VPC boundary. So these guys all will ensure that yeah, your data is safe, the incoming data is safe. So that's
Yeah.
all.
Can you guys hear me?
Yeah.
So one of the thing about security, when the cloud became prominent, the technology was good, EC2 servers were good, VPCs were good, and it was giving very cheap actually to attract the newbies into the market. But the real challenge was people were not trusting it. Like how should I put my data into somebody else multi-tenant environment, right? So see, cloud is whatever you say, it's still a multi-tenant environment. You don't know where the heck, which rack, where your data is being set and who can see what, right? That was the primary reason where after 6-7 years of the AWS success, because of all these products and because of the promise of the security and the way you see that there are layers and layers and layers of security they built around. So it is not one product is doing everything. So they have one for DDoS, denial of service is one of the biggest thing in the on-premise thing. So they knew that if that is going to happen for on-premise, it is bound to happen for the cloud. So they already came out with the service for that. And some of the services are actually peanut. The price-wise, they're not making too much money on these security services per se, but they gave all these beautiful services so that you trust the cloud. then they make money on the other services. These services are all gaining the trustworthiness so that you could put your valuable data in a multi-tenant environment. Um, that is one of the beauty of it. And in exam, they will ask something like, if you have a Facebook account or if you have a Google account or something, how easily you could log in into the AWS account. So Cognito is one of the things where that is a bridge between your other IDs could leverage and tell you who you are, so that you could use it easily. So that is one of the thing. And if you see most of this, if you look at the name of the service, it kind of tells you what it is. And this is, remember we talked about networking, security group, and the NACL rules, routing tables. And now these, along with that, those are all the networking side of the security. This is once you get into the AWS, so that will tell you whether who can let you in. But once you come in, these are the things tell you what services you have access for. By default is zero security. If you don't give any permission, if you just come to your account, you create an account, you create a service, only the guy who created the service can able to use it. If anybody else want to use it, you have to go here and give the permissions separately in every layers. Through this layer, this is one of the very, very important topic. They have a quite a substantial percentage also, questions wise. And it's kind of an easy hanging fruit if you think about. So if you guys follow these tools, understand it, then if you look at the questions, it make a lot more sense.
Yeah.
So, Srini,
Yeah.
what is there? Means these are all Amazon products, right? Like, so just
Yeah.
querying, like, what about anything that is in-house that you can integrate, like say for
Yeah. So now,
Microsoft LDAP?
yeah. That is all. The elder thing is, for example,
Yeah, in IAM there's something called
directory service, right?
federator identity. Okay, federator identity, sorry, identity federation. So identity federation is a component inside this IAM where using that you can bring your in-house users and all the credentials inside. It has integration to all the popular LDAP or Active Directory, or all those integrations are all possible. So this IAM is a very big product, like VPC on the networking side or EC2. So this is also it's a very big product. So in this there are a lot of subcomponents inside. So yeah, one very popular use case is bringing your existing corporate data into IAM, because you don't have to create your own create a new credentials for your existing users. So yeah, this has integration to your corporate products like LDAP or Active Directory and any other corporate popular products. And also it has integrations to even your Facebook and social media user ID passwords also. So this is something, very common questions that will come under this category in exam also. For example,
So Shyam, yeah, I would recommend you take one detail next week, zoom into the IM. Okay, if not demo side, just you could just show bit of it, but little deep on the IM might help all of you, as well as it will give confidence while taking exam.
yeah, agree. So this IAM product is a broader scope. So yeah, spend more time in IAM because it's very important from exam point of view. Yeah, I will also try to touch base more on IAM maybe in the next session. Okay, I think I think we are already running short of time. So I think so. Just to summarize, maybe I will share this PPT with you. I think this is not going deep dive. But it just gives one liner. This one liner, if you remember, you can drill down further based on, at least you can narrow down the options that you get in the questions. So yeah, like even from exam point of view, at any time if someone asks you what is this, you should be able to tell what is the product. So just keep this, remember this use cases for so a threat detection system, then guard duty, for example. So like relate these scenarios by this one-liner. So it is easy to knock down most of your questions that you get in exam. But yeah, of course, it's not just this is sufficient. You need to deep dive in some of the products because there will be some questions scenario based, some questions will be feature based also. So feature based is like you need to understand these products in detail also to at least some of the products, not all, but some products you need to go a bit detail at feature level. So yeah, I think anyway you're studying this, so you'll enter into that space. But yeah, this is at a high level, so kind of a ready reckoner for you to before going to the exam. So yeah, but yeah, just to summarize, I think since we're running short, so we'll continue this session in the next week also. But we have more sections covering the storage category, management and governance, application integration, analytics, developer tools, migration. So of course, yeah, cost management, of course, customer engagement. So these are various categories that you have. Again, don't think that there are a lot of things are there, but these are all. It is from exam point of view, the core products are important. So that's where you need to spend more time. So once you understand the core product, then others are all at a high level that you need to know. That's all. So yeah. So anyway, we'll touch up the following sessions of the rest of the slides. But apart from this, what I am preparing one more presentation, which is primarily it's kind of a notes, reckoner notes for you. So it's more about what are the important things from exam point of view that you need to know. So like a short summary. Uh, just before you're going to the exam, it's kind of a refresher for you. Um, so one liner, not. So this is something you need to remember just before the day of exam. So like just prepare. So this is that kind of a summary notes I'm preparing. I think it is. I just start compared EC2. EC2 itself is a very big topic. So, but yeah, I will share you this also. Like for example, I think we already saw this in EC2. What is like public IP, private IP, elastic IP. Then yeah, EC2 user data, pricing options, on-demand, resort, spot, dedicated instances. So and what are the popular instance types that we have? General purpose compute memory. So uh, yeah, and what is the AMI? Uh, so and also what are the placement strategies of EC2? Cluster, spread, partition. So what is ENI? So yeah, likewise this I'm just comparing. There's a lot of work is there, but I think I need to prepare for other slides. But it's kind of my own exam preparation I'm preparing. Maybe I will share this content. But yeah, I think I will spend more time on this category also. Okay, so that's all I have for today. I will share this PPT and put this in the Google Drive, usual place, and I will send an email. Yeah, I can take a look.
Yeah,
Thanks a
I
lot.
think it's a good luck, guys. So enjoy the journey.